Welcome to another episode on this channel. Today we are going to be looking at matrices. Let's dive straight into it. Let's consider a theorem. That is, let A be a squared matrix over a field. Then A is said to be invertible if and only if determinant of A is not equal to 0. That is, A inverse will be equal to the determinant of A multiplying adjoint of A. An example is, if we have a matrix A of the form then determinant of A will be AD minus BC, which is not equal to 0. Then our A inverse will be equal to AD minus BC all inverse times the adjoint of the matrix A. And the adjoint of the matrix A is we interchange D and A and we negate C and B. Now let's look at a corollary. Let A be a squared matrix over a commutative ring Zn. Then A is invertible if and only if the determinant of A belongs to the invertible element of Zn. That is, the GCD of determinant of A and N is equal to 1. Okay, so now let's look at an example. Let P be equal to a ring 26 and A be a 2 by 2 matrix over P. Now, if A is equal to 2, 7, 14, and 11, the question is A invertible over Z 26? Now let's check. Before A will be invertible, we first have to check if the determinant, the GCD of the determinants and the modulus N. So in this case, our N is 26. If the GCD is equal to 1, then it means our matrix A is invertible. So the first thing that we have to do is we have to check for the determinant of A. So the determinant of A is 2 times 11 minus 14 times 7. And that is equal to 22 minus 98, which is equal to minus 70 6. Then modulo 26, and that is equal to 2. So now the GCD of over here, the determinant of A is 2 and our n is 26. And the GCD of 2 and 26 is not 1. Now since the GCD is not 1, it means that matrix A is not invertible over Z26. Okay, let's check out the second example. Example 2. If A is equal to 5, 14, 7, and 11, the question is, can we find A inverse? Okay, so the first thing is, let's find our determinant. Determinant of A is always equal to 5 times 11 minus 14 times 7. And that is 55 minus 98. And this is equal to minus 43 mod 26. And this is equal to 9. The GCD of the determinant of A, which is 9, and n, which is 26, is always equal to 1. So since this is equal to 1, then it means A is invertible. Now, if the matrix A is indeed invertible, how do we find it? So A inverse is equal to, now remember the formula over here. The formula said the determinant inverse. So in our case, the inverse of 9. So we are going to get 9 inverse times our adjoint. Our adjoint is 11, 5. We interchange the diagonal entries and negate this part, minus 14 and minus 7. So now, what is 9 inverse in modulo 26? So as we've done so far, 9 inverse in Z26, just a reminder, you can calculate it this way. 26 is equal to 9 multiplying 2 plus 8. Then 9 is equal to 8 by 1 plus 1. So to find the inverse, we are going to get 1 is equal to 9 minus 8. Then 1 is equal to 9 minus, then we do the substitution. So 26 minus 9 times 2. So we are going to get 9 times 3 minus 26 times 1. So the inverse of 9 in modulo 26 is 3. So in this case, 9 inverse is equal to 3. We're going to get 11 minus 7 modulo 26 is 19. Minus 14 modulo 26 is 12, and we have 5 over here. So we just multiply it through, and we are going to get 33, 36, 57, and 15. So our result in modulo 26 is going to be 7, 10, 5, and 15. And this is equal to our A inverse. I hope this is clear. So first of all, if you want to know if a matrix given to you is invertible, you have to find a determinant of that matrix. If the determinant of that matrix and the modulus given is co-prime, then it means that an inverse indeed exists. Then we go through this process to find it. Okay, so I want us to look at this. So we have this, given a matrix A, which is equal to 2738. We have to decrypt QV NA YQ HI. Okay, so this is a question that I want us to look at. So given this, there are some formulas that we have to take note of. The first formula is our cipher test will always be of the form matrix A times P, where P is our plain test. We also have our plain test, which is P, will always be equal to the inverse of A times our cipher test C. And if we want to find A inverse is the same as our plain test P times the inverse of our cipher test, which is C. Now, looking at this question, if we want to decrypt this, then it means that over here, what we have here, this is our cipher test. Okay, so our C is equal to this. Now, to find P, we know that P is equal to A inverse of C. So the first thing that we have to do is we have to check if A is indeed invertible. Now, let's find the determinant of A. Determinant of A is equal to 2 times 8 minus 7 times 3, which is 16 minus 21, which is minus 5, and modulo 26 is equal to 21. And the GCD of 21 and 26 is equal to 1. So indeed, an inverse for A exists. Now let's continue to find it. We are going to get A inverse is equal to the determinant inverse multiplying our adjoint, which is this, and 21 inverse modulo 26 is equal to 5. Minus 7 modulo 26 is 19. Minus 3 is 23. Then we have 2. So if you multiply this out, you're going to get 40, 95, 115, and 10. And this in modulo 26, we are going to get 14, 17, 11, and 10. Okay, so now since we have A inverse, let's find our P. We know that P is equal to A inverse times our C. So P is now, our A inverse is 14, 17, 11, and 10. And our cipher test was given to us as this. Sorry. So this is our cipher test, right? So now, let's write our cipher test in the form of a matrix. Now, Q corresponds to 16 in the English alphabet, right? So Q is 16, V is 21, N is 13, A is 0, Y is 24, Q is 16, H is 7, and I is 8. Now, if you multiply this two matrices and you find your answer in modulo 26, this is what you're going to get. 13, 14, 0, 13, 18, 22, 4, and 17. Now, let's read this message. Our P will be equal to, what is 13? 13 is N, 14 is O, 0 is A, 13 is N, 18 is S, 22 is W, 4 is E, and 17 is R. So our plain test is no answer, and our cipher test is this over here, QVNAYQHI. So if we were told to encrypt no answer, we would have gotten our cipher test, which is the QVNAYQHI. Okay, thank you. Now let's move on to the second problem. Okay, so for the second question, it goes this way. Suppose that we know our adversary is using a 2x2 encipher matrix with a 29-letter alphabet, where A to Z have the usual numerical equivalents that we know. Blank is 26, question mark is 27, and exclamation mark is 28. We receive the message GFPYJP space X question mark UYXSTLADPLW. So that is our cipher test. Then the question also continues that the last 5 letters of the plain test are our adversary signature, which is Scala. Then we should read the message. Okay. So before we do this, we have to know our cipher test and our plain test. Okay, so looking at this, we know we have to write this in the form of a matrix, but the last 5 letters of our plain test is Scala. Now we can't write 5 in a matrix, right? If it was 6, we could have written it in a matrix, or if it is 4. So the best idea is to use the last 4 letters instead of the 5. So our C will now be ARLA. Instead of color, we omit the K and use the last 4 to form our matrix. Our P will be equal to so P is equal to this. Now then C is equal to the last 4 letters of the cipher test. So the last 4 letters are D, P, L, and W. So D, P, L, and W. Okay, so looking at the previous question, we can see that matrix A was given, but in this case there is no matrix A. So what do? First of all, we have to find our A inverse, right? Okay, so P is equal to A corresponds to 0. So we have 0, R is 17, L is 11, A is 0, and C, D is 3, P is 15, L is 11, and W is 22. Okay, so now we know that A inverse is always equal to PC inverse, right? So to find C inverse, you have to check if C is invertible. Now the determinant of C is 3 times 22 minus 15 times 11, which is equal to minus 99. And we are dealing in modulo 29, so this is equal to 17. Now let's see if they are co-prime. So the GCD of 17 and 29 is indeed equal to 1, meaning that C is invertible. C inverse will be equal to our 17 inverse multiplying the adjoint, which is 22 minus 15 minus 11 and 3. 17 inverse in modulo 29 will give you 12 if you go through the Euclidean algorithm. We have 22, we have 14, 18, and 3. And this in modulo 29 will give you 3, 23, 13, and 7. So now, after knowing our C inverse, let's find our A inverse. So A inverse is equal to our matrix P, which is 0, 17, 11, and 0. Multiplying our C inverse, which is 3, 23, 13, and 7. If you multiply this in modulo 29, you are going to get 21, 22, 19, and 18. Okay, so now if we want to read our message, then we have to find our P, and P is always giving us A inverse of C. Now, A inverse is what we have over here, which is 21, 22, 19, and 18. And what is C? C is a cipher test that was given in the question. So we have JF, PY, JP, then a space, SM question mark, UY, X, S, and T, LA, DP, and LW. So now we have to write this cipher test in the form of a matrix. So we know that J is 6, 5, 15, 24, 9, 15, 26, 23, 27. Note that question mark was given as 27, right? U is 20, we have 24, 23, we have 18, 19, 11, 0, 3, 15, 11, 22. So this corresponds to our cipher test. This matrix over here is our cipher test, and this over here is our A inverse. Now we want our plain test. If we multiply this in modulo 29, our plain test will be this. So this will be the result: 18, 19, 17, 8, 10, 4, 26, 0, 19, 26, 13, 14, 14, 13, 28, 10, 0, 17, 11, and 0. So let's try to read this message. So our plain test will now be 18 is S, 19 is T, 17 is R, 8 is I, 10 is K, 4 is E. And remember, 26 is blank, so we leave a space. 0 is A, 19 is T, 26 is blank, so we leave a space. Then 13 is N, 14 is O, 14 is O, then 13 is N again. 28 in this case was given as exclamation, so you bring the exclamation. 10 is K, so we have 0 is A, 17 is R, 11 is L, and this. So you can see that the last 5 letters of the cipher test is color. So the message reads strike at noon color. So this is the solution to this problem. I hope it helps. Thank you. If you like this channel, please give it a thumbs up, like, share, and subscribe. See you in the next video. Bye.